Hello friends, this is part 2 of kinematics, and here we're gonna discuss how to draw graphs for different kind of motions, a uniformly accelerated motion, object moving with constant velocity, right? We're gonna draw position and time graph, velocity and time graph. Okay, we're gonna discuss those things, and we are going to solve previous year's questions which are asked in NEET and JEE related to these topics. That means those graphical problems, right? So now let's start. Before we start, please subscribe the channel. Also share with your friends. Hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Right. So now let's start. So first let us draw position and time graph. Suppose an object is at rest. First, when the object is at rest. So here you see, let me take this horizontal axis as time graph and the vertical axis as position. Suppose here you see, this is the origin and this is the x-axis. Suppose with respect to the origin, there is an object which is at rest. At rest. Suppose it is x naught meter away from this origin, then if it is at rest, it always be at the same position, right? At t is equal to 0 second, at t is equal to 1 second, at t is equal to 3 second. As it is in rest, doesn't matter what is the time, if it is t is equal to 0 second, 1 second or 3 second, so it will be at this position. There will be no change in position. So at time t is equal to 1, 2, 3, so suppose this is the position, this is the position axis. Here you see, this is the point x naught is the initial point. So after 1 second, 2 second, it will be at the same position. So the graph should be like this, which is parallel to the time graph, time axis. So hope you have understood this. Now let us draw a graph for an object moving with positive constant velocity, right? Suppose object moving with positive constant velocity. So what going to be the graph? Now you see, this is the x-axis. Suppose an object is moving along x-axis, and this is the origin, and this is the object which is moving along x-axis, right? And as it is moving with constant positive velocity, that means it will move towards positive x-axis. We're going to consider that way. So we're going to consider that towards the positive x-axis, the velocity is positive. Velocity is positive. Velocity is positive. We're going to consider that way. So if it is moving with constant velocity, right, here you see, suppose it is at 0 second, it is at origin. After 1 second, it is suppose 1 meter away from the origin. After 1 second, it is suppose 1 meter away from the origin, right? At t is equal to 1 second, and at t is equal to 2 second, suppose it is 2 meter away from the, it's 2 meter away from the origin. So in each second, so its displacement is 1 meter, so 1 meter per second you can consider here. The velocity is 1 meter per second in this case, right? So now you see, this is 1 meter, then after 2 seconds it's 2 meter, then after 3 seconds it will be 3 meter, and so on, right? So that's why here you see, so 1 meter, 2 meter, 3 meter, after 1 second, 2 second, 3 second. So in that case, so what will be the graph gonna be look like this, right? So it seems to be like this, sorry. So this is gonna be a straight line, right? So hope you have understood this. So this is for an object moving with constant positive velocity, right? So what if it is moving with a constant negative velocity? So then the graph should be like this. So here the horizontal axis be the time axis, and this is the position axis, and here you see this is the opposite direction. Suppose this is x dash, right? X dash. So velocity is negative means, so the object must be moving towards negative x-axis. We're gonna consider that, right? If the positive x-axis is considered towards the positive x-axis, we have considered the velocity is positive, then towards the negative x-axis it will be considered as negative. So the graph gonna be look like this. So this is gonna be graph for negative velocity. This is the graph for object moving with negative constant velocity is moving with negative constant velocity. Okay, that means here negative constant velocity. So negative constant velocity. So what does it mean? That means acceleration, constant velocity means acceleration is equal to 0. Now how to draw a graph, an object moving with positive uniform acceleration? Let me show you an example. Suppose this is the x-axis, suppose, and here is the origin O, and this is an object at t is equal to 0 seconds. Suppose t is equal to 0 seconds. This is the position. Suppose it is 1 meter away from the origin, right? So after 1 second it travels, suppose 1 meter. So this is the new position of the object. Suppose it travels 1 more meter, that is this position is 2 meter now, right? It has traveled 1 meter in 1 second. First 1 second, here t is equal to 1 second, and next 1 second it travels, suppose 1.5 meter. That means the new position will be when t is equal to 2 seconds. New position is suppose 3.5 meter. That means it has traveled a distance of suppose 1.5 meter, right? In the first 1 second it has traveled only 1 meter, right? So in the next 1 second, suppose when t is equal to 3 seconds, the object is at this position, which is suppose 5.5 meter, right? So here you see, in this case, velocity while going from this position to that position, here you see velocity was 1 meter per second. In the first 1 second it traveled 1 meter, and the next 1 second it has traveled 1.5 meters. So velocity is now 1.5 meter per second during this period of time, 1.5 meter per second. And the next, and in the last 1 second from this position 3.5 to 5.5, so it has traveled 2 meter per second. So in the last 1 second it has traveled 2 meter. So in last 1 second, so velocity is increasing in each second by 0.5 meter per second, 0.5 meter per second square. So this is the acceleration, right? This is the acceleration. So if you want to draw this graph, then you're gonna get the graph like this. Suppose this point is suppose 1 meter at t is equal to 0 second, and then you have, this is 2 meter, this is suppose 3 meter, then this is 3.5 meter. Suppose this is the 3.5 meter. Let me mark it green, the positions of the object. And this is the after 3 meter we have 4 meter. Suppose this is 4 meter, right? And next we have 5 meter, and this is the 5.5. Suppose this is the 5.5. Let me consider that way. So 1 second, 2 second, 3 second, its division must be equal 4 second. So when t is equal to 0, the position was 1 meter. Its position was 1 meter away from the origin. So here is 1 meter, this is suppose 2 meter, and this is 3 meter. So it is a 3.5. This is 3.5 meter, and this is 4 meter. This is 4 meter, and this is 5 and this is 5.5. Suppose 5.5 is this, so let me consider that way. So here you see, when t is equal to 0, so this is the position 1 meter away from the origin. When t is equal to 1 second, when t is equal to 1 second, the position is at 2 meter. This is 2 meter away from the origin. And when the t is equal to 2 second, the position is 3.5 meter away from the origin. This is 3.5, and at the last 1 second here, so position is 1.5, sorry, 5.5 when t is equal to 3 seconds, right? So graph, the shape of the graph should be like this. This is the graph, right? So that means you can you will obtain this kind of graph. Let me show you. So let me clean this. So this is the time axis, and this is the x-axis, position axis, and this is 0, the origin. Then the object moving with acceleration, positive acceleration, the graph, shape of the graph will be like this. Okay, so this will be the graph. And if the object is moving with negative acceleration, it will be, concave downward, right? So its shape will be like this. If it is moving with negative acceleration, so when a is greater than 0 and when a is less than 0, right? So this is when object is moving with negative uniform acceleration, right? So this is going to be the graph for negative acceleration, right? So now let us draw velocity and time graph. Let us draw velocity and time graph for an object moving with constant velocity. Here you can see, let me take the axis. Here this is velocity and this is time. Horizontal axis represents time and the vertical one represents velocity v. So an object is moving with constant velocity, initial velocity. Suppose it has some initial velocity. This is the point which represents the velocity of the object. As it is constant, so velocity is not going to be changed with time, so that's why it's going to be parallel to the time axis, right? It has fixed velocity. Suppose its velocity is 5 meter per second. Let me say that 5 meter per second. Let us say this is 5 meter per second initial velocity. As it is constant, when t is equal to 0, then its velocity is 5 meter per second. When t will be equal to 1 second, then also its velocity 5 meter per second. When t is equal to 2 seconds, then also its velocity 5 meter per second. So when t is equal to 3 seconds, then also its velocity 5 meter per second. So that's why this graph going to be parallel to the time axis. So hope you have understood this. Now what if an object moving with constant velocity but negative velocity? This is positive velocity, right? So what if it is moving with a negative velocity? So that means here you see, this is the time axis, this is the velocity, and this is the 0. So this is suppose negative v, right? So then it will be parallel to time axis, negative constant velocity, right? So we have to draw this way. This is negative constant velocity, and object is moving with negative constant velocity. Here minus v is the negative constant velocity. Then we have to draw the graph like this way. So hope you have understood this. Now what if it is accelerated motion, not moving with constant velocity, right? Here the velocity is negative constant velocity, right? So what if it is accelerated motion? So now you see, suppose here you see, this is the time axis suppose, and this is velocity v, and this is the origin O. So accelerated motion, suppose moving with an object moving with, suppose an object moving with an acceleration, positive acceleration, then this velocity gonna be increasing uniformly, right? So it is uniform acceleration, suppose. So then the graph gonna be like this, because it's an every second the velocity is increasing. You can see clearly velocity is increasing, right? So if it is negative acceleration, that means retardation, negative acceleration, then the graph gonna be something like this. So this is the time axis, this is the velocity, and the velocity gonna be decreasing, so graph gonna be like this, right? So if the velocity is decreasing, and again one more thing, suppose let us consider such kind of motion. Suppose this is an object is moving with a velocity towards positive x direction, and its velocity is decreasing. That means it has suppose negative acceleration. Velocity is decreasing at a point it reached v is equal to 0. The velocity is 0 meter per second. Then it returns in backward. It is coming back in opposite direction. Now velocity started increasing in negative direction, right? So we are going to get negative velocity. Then in such kind of motion, it is going forward and again coming backward with the same acceleration, right? Negative acceleration. Then the velocity and time graph should be like this, right? At this moment, at this instant, the direction of the motion is changed, right? So hope you have understood this situation. Suppose you have thrown a ball upward, right? At the maximum height, its velocity gonna be 0. Again it will be coming down, right? So then velocity will be increasing, but in opposite direction. That's why this kind of motion will be represented by this graph, right? While it is going upward, it has a positive velocity and it is increasing with acceleration equal to z, and again sorry, not increasing, the velocity is decreasing with acceleration minus z, because z is acting downward, right? Then again while it is coming downward, then velocity is increasing. Now the direction of velocity is in opposite direction, so it is negative velocity. So we have got two phases here. One is after here you see at the maximum height, suppose time is t, at this moment this direction of the motion is changed. So here now velocity and time graph after time t, this part is represented by this red color part represents the negative velocity after reaching the maximum height, right? So hope you have understood this. Now let's move on to, if we solve problems related to graph, we must know equation of a straight line, different form of equations of a straight line. Straight line. The general equation, the slope form is given by y is equal to mx plus c if the slope is known. Okay, if the slope is known, suppose this is x and y axis and this is a line and it makes theta angle with positive x-axis, then m is given by tan theta, right? And if you know any point on this line, then you can if you know this point, suppose x comma y, then tan theta will be given by y by x, because this is x, right, and this is y. So y by x perpendicular by base gives the tan theta, right? So and putting the value of x and y, you can calculate c, and putting the value of m, right? And now equation of a straight line can be written in intercept form also. So suppose this is the x-axis, this is y-axis, and the line cuts x-axis and y-axis at suppose a comma 0 and 0 comma b. At these 2 points the line cuts the x and y-axis respectively. Then x by a plus b by, y by b, y by b is equal to 1. This is intercept form of straight line, right? Now you see, if you know the know 2 points on a straight line. So we don't know what type of straight line is this. Suppose if this is x-axis, this is y-axis. If you know 2 points here on this line, suppose those 2 points are, suppose x1 y1 and this is x2 y2, then the equation of that line will be given by y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1, right? So this is also equation of a straight line passing through 2 points, 2 given points. These are the 2 points, right? And now let us discuss about parabola. That is also equation of parabola. So now you see, suppose this is x-axis, this is y-axis, and this is a parabola, and if it is passing through the origin, that means origin is the vertex and its focus is suppose a comma 0, then equation of, there is a point suppose x comma y, and equation of this parabola will be given by y square is equal to 4ax, right? Or it can be written as y is equal to plus minus root over 4ax. And again, if here you see x-axis is the line of symmetry, here axis of symmetry. If the parabola lies somewhere in the first quadrant, suppose, or second, third quadrant, anywhere, so if the line of symmetry is not the x-axis, right, axis of symmetry is not the x-axis, and this vertex is now h comma k, suppose h comma k, and its focus is suppose now here you see this length is h and this length is suppose a, then h plus a comma k, that will be the focus, right? Now in this case, equation will be, this is the equation for this case, right? And for this case, the equation will be y minus k whole square is equal to 4a x minus h. This is going to be the equation of the parabola, right? So now let us solve this question. Here you can see that the given graph, this graph, they are talking about this graph, it shows that variation of velocity with respect to displacement, okay? And now we have to find out that which one of these 4 graphs, out of 4 graphs, which one is representing this graph, right? So in the options we have acceleration versus displacement graph, right? So which acceleration versus displacement graph represents this given graph, that has to be determined. Okay, so now let's start. Now you see this these 2 points, here you can see this point is x naught comma 0 and this point is 0 comma y naught, right? Sorry, v naught. So we have the x and y intercepts. So straight line of intercepts from equation of a straight line in its intercepts form, I have already given you that. So if this is x-axis, this is y-axis, this is the straight line, it intersects x-axis at a comma 0 and y-axis at b comma 0, 0 comma b, then its equation is given by x by a plus y by b is equal to 1, right? So similarly, here you can see, if you compare this with these 2 points, if you compare these 2 points with a comma 0 and b comma 0, then equation of this graph will be given by v by v naught plus x naught x by x naught is equal to 1, right? So now let me clean these things. Okay, so now you see, if we simplify this equation, then what we're gonna get, we're gonna get v naught minus v naught x by x naught. That's what we're gonna get, right? So now if you differentiate with respect to x, dv by dt, dv by dx, dv by dx, then what you will get, v naught will be 0. Let me differentiate with respect to t. Okay, if you differentiate it, then we used to consider that the initial velocity is constant. So if you differentiate it as with respect to t, it will be 0. Then this part, initial position and initial velocity, this ratio will be taken as constant. So v naught by x naught, then again dx by dt, because displacement varies with time, right? We can assume that way. Then dv by dt is nothing but acceleration a, and minus v naught by x naught, dx by dt is nothing but v, right? So here you see v is equal to this equation. From this equation, what we will get, we will get the value of b. Let's put here. Let us put the value of b from 1 here. Then what we will get, a is equal to minus v naught by x naught, and v will be replaced by v naught minus v naught x by x naught, right? So here we have used 1, right? So now let me clean these things. Okay, just wait. So here you see a is equal to, now if you multiply on the right hand side, here what you will get, v naught square by x naught minus plus, here you will get v naught by x naught whole square into x. So it can be written in this form, v naught by x naught into x, v naught by x naught whole square into x minus v naught square by x naught, right? And here you see, if you compare this equation with y is equal to mx plus c, right? Here y-axis is the acceleration, right? Okay, now you see this slope m is positive here. This is positive, v naught square by x naught square, that's gonna be positive, right? This is positive, so we have got positive slope. And here value of c is minus v naught square by x naught, which is negative. This is negative. So c value is negative, means this line intersecting y-axis, that means here acceleration axis at this graph should be something like this. If the slope is positive, this line must be inclined with x-axis in this way, right? In this manner, right? That means it must make angle between 0 to 90, angle between 0 to 90 with the positive x-axis. Then only we will get positive slope, and it must intersect y-axis at it must intersect negative y-axis at negative y-axis, right? Then only we will get c negative. Okay, so here we are getting this negative, that means it is intersecting the y-axis at below the origin, that means at negative y-axis. Okay, intersection is at negative y-axis, and the y-axis is here acceleration. Okay, so this y-axis represents acceleration. So which graph will be correct? So here you can see slope of this line is positive, because it makes angle theta, which is between from this figure you can see clearly it is between 0 to 90, right? And here you can see it is intersecting the acceleration at negative y-axis. So that's why this equation satisfies this figure, right? So that's why this is our answer. So hope you have understood this. Now let me go to the next question. See, a body is thrown vertically upward. Which one of the following graphs correctly represent velocity versus time, right? So here you see, when an object is thrown upward, right, then what will happen? The velocity will be decreasing, right, as it goes upward, and gravity pull it downward. So that's why its velocity will be decreasing, right? So we used to consider this direction is positive, this direction is negative, right? So when you will draw the graph, velocity versus time graph, okay, so initially it will going as it is going upward, velocity is decreasing, right? So velocity should be decreasing this way with time, right? And again at a particular time, its velocity at maximum height, its velocity will be 0. Here the velocity will be 0. Then again it is coming down. When it is coming down, velocity will be increasing, but because of the direction, the velocity will be negative while coming downward, and while going upward it will be and the velocity is positive while going upward, but while going downward velocity is negative, right? We have taken the direction downward is negative and upward is positive, right? So now you can see that while coming downward, the velocity towards minus b, it is increasing, right? So this type of motion mentioned in this question will be represented by this graph b, right? So hope you have understood this. So now let's move on to the next question. That here you can see this one. All the graphs below intended to represent the same graph, okay? So one of them does it incorrectly. Pick it up. So here you see all the four graphs are drawn to represent one kind of motion, and we need to pick the wrong one, okay? So here you see, from the first graph you can see this is velocity and time graph. Recently we have done, right? So in this question, this graph represents a motion of this kind, when something is thrown upward and again it is coming down, right? Or you can say if something is going forward, again it is coming back, we will get this kind of graph in such kind of motion, right? So now you see, next graph is given, that velocity and position graph. So here you see velocity and position graph. Let me check it is correct or not. Here you can see this is velocity and position, this is x, this is v, right? So as it is going upward, if the object is going upward, right, and from 0 to something else, the position is increasing, right? 1 meter, 2 meter, and so on, right? So but velocity is decreasing. Here velocity is decreasing, this height 1 0 0 1 2 3, this is increasing. That means the graph should be something like this. So position is increasing, velocity is decreasing, right? And similarly, while coming downward, that position will be reduced, this height will be reduced from 2 meter to 1 meter, 1 meter to 0, like that, but velocity will be increasing. Velocity is increasing towards negative velocity, right? So this graph is also correct, okay? This graph is also correct. These two graph first two graphs are correct. They are both representing the same motion, right? So next, this graph, third one, you can see distance and time graph. Here we have distance and time graph. This is time, this is distance, So the first part of the graph is something like this, and second part is something like this. So in the first two cases, here you can see, in these two cases, if an object is vertically thrown and it is coming down, right, the that means you see, the acceleration should be negative, right? Acceleration should be negative. It is because you see, when something is moving with a initial velocity and the velocity is continuously decreasing, then acceleration will be negative. And again it is acceleration is negative because velocity is decreasing. Now velocity is decreasing means the direction of acceleration will be in opposite direction of the motion. Again it is coming back in backward direction. The when it is coming backward direction, its direction is along the this direction of motion is the same as the acceleration. In that case the velocity is increasing towards negative direction, right? So in both cases the acceleration is negative, right? So in the whole journey the acceleration is negative. But in this case you see, when you remember one thing, that in case of distance and time graph, if you get the graph concave upward, this side is concave, then it represents positive acceleration. Again, if it is concave downward, this side is concave, then it represents negative acceleration. So here we are getting positive and negative acceleration, so it doesn't represent the same motion as the first two, right? And last one, let me check. So there will be one incorrect, so option is C. It is clearly we have got the answer. So let me analyze the fourth graph also. So now you see the position and time graph. So here while it is going upward, then the position will be like this: 0, 1, 2, 3. It will be increasing, right? Position is increasing, right, with time, like that. Again, while it is going downward, then 3, 2, 1, 0, it is coming in reverse, right, with time. So this graph also satisfies this situation, this type of motion. So same by these three graphs, so A, B and D, represented by three graphs, the same kind of motion is represented by these three graphs. Only the odd one is the C, graph C. So that's why our answer should be C. So hope you have understood this. Now let's move on to next question. So this is our next question. A particle starts from origin. So here you can see a particle, this is x-axis position, start from the origin to move with a uniform acceleration. That means it is not changing with time. Okay, so acceleration is uniform acceleration along positive x-axis. So identify all the figures that correctly represent the motion, right? So we have to identify all the graphs which are representing this situation correctly. Okay, so now you see, first let me check the first one. So here you see the acceleration is uniform, that means it is not changing with time. So here you see the acceleration is uniform, here it is not changing with time. Okay, if the acceleration had increased or decreased, if it is increased, the graph should be something like this. If it had decreased, it should be like this, right? But here it is parallel to time axis, so that's why here it represents uniform acceleration. So this graph is correct. Now, as the object is moving with uniform acceleration, the velocity time graph should be this. This is correct because we have already discussed the graphs when object moving with positive uniform acceleration, um, then velocity and time graph is something like this. We have already discussed these things, right? We have already discussed about the graphs. This graph velocity and time graph also representing this motion. And also we have seen that the position and time graph for positive acceleration is if the initial position is from the origin, then, so I had shown that for positive acceleration, position and time graph is of this shape. So this is correct for those kind of motion if the motion is not starting if the object is not starting from the origin, it has some initial position x naught, suppose. So if it is starting from the origin, then the graph should be started from the origin, right, of this shape. So this graph is starting from origin. So this is for positive acceleration, right? And it is uniform acceleration. And I have shown this graph. We have already discussed this kind of graph. So this graph is also representing this motion. But here you see this graph, here you can see. So this is the position, how the position is changing, and from this part the position is fixed with time, not changing with time. So it doesn't represent this situation. So hope you have understood this. And also in this part here it is concave downward, so here acceleration is negative. That is also important thing. So it doesn't represent the motion which is mentioned in the question. So our option will be A B D. So D option is correct. So hope you have understood this. This is the answer, option D. Now you see, this is the next question. A particle starts from the origin at time t is equal to 0 and moves along the positive x-axis. The graph of the velocity with respect to time is shown in the figure. This is the velocity and time graph given in the figure, and we need to find the position when the time is 5 seconds, right? So in order to find a position, we're going to find displacement. Now remember, velocity and time graph, the area below the velocity and time graph gives displacement, right? Displacement. So in order to find the position, we must know the displacement, right? That displacement will give the position, right? So here you can see that clearly at 5 seconds. Let me draw the line here. So this is the time axis, right? Here you can see this is time axis. So at 5 seconds, from 0 to 5, right? Let me find the area of this part. Okay, first let us find the area of this triangle, then we're gonna find the area of this part, right? Then we are to find the area of this part. Okay, then sum of all these three will give the displacement. So area of this triangular part, here the base is 2 and the height is also 2. So area of this will be half into 2 into 2, then plus. So now base is here 4 and 2, that means 4 minus 2, that's going to be equal to 2. This length is 2 and this height is also 2. So 2 into 2, then plus we need to find the area of this, right? This area. So here you can see this is this length is from 4 to 5, it is 1, and height is 3, right? 3. So 3 into 1. So here 2 cancels, 2 plus 2 to the 4, 3 1 the 3. So that's going to be equal to 6 plus 3, that's going to be 9, right? 9 meter. So D is the correct option. So hope you have understood this. So let's move on to next question. So displacement and time graph of a particle is given here. So here you see we need to find the instantaneous velocity of the particle is negative at the point when the instantaneous velocity will be negative. Now remember one thing. Suppose this is a velocity and time graph. If you draw tangents here, sorry, this is at a particular time, this is time and velocity graph, and if you draw the tangent here, suppose this is the graph, velocity and time graph, and if you draw tangent here at this point, at this particular time, then the slope of this tangent gives the instantaneous velocity at this particular instant, right? So now slope of this line will be positive if this angle made with the positive time axis is between 0 to 90. So here you see this angle is between 0 to 90, right? Then only we will get positive slope, and positive slope will give you the positive velocity, right? And if the tangent is in this shape, inclined to this axis, time axis, in this way, so here's you can see angle with this time axis is greater than 90. So here it is 90 pi by 2 and it is greater than 90. Now this angle theta is now greater than 90. So in that case you will get negative slope and then velocity will be negative. So here you can see clearly, if you draw a tangent at this point E, right, at this point E, then you gonna get a negative slope, right, a negative slope. So that's why because this angle, you can see this angle is more than 90, this is 90, right? So it is exceeding the 90-degree angle, right? So that's why the option D, that means at E, at the point E, at this time we're gonna get the negative velocity, instantaneous velocity. So hope you have understood this. Now let's solve the next question. So this is the next question. Which one of the following curve doesn't represent motion in one dimension? Now you see, these are the graphs, velocity and time graphs. Okay, so if at a single point at the same time, at a particular instant, if we get two velocities, right, then it represents two-dimensional motion, right? That means at the same time you are getting two different velocities, means the velocity has two components. Okay, suppose this is x-axis, this is y-axis, and a particle is moving in this direction with velocity v. If it travels parallel to x-axis, then only x coordinate will change, but if it travels along y-axis, then y coordinate will change only. If it travels in this direction, in neither parallel to x nor y, then both coordinate will be changed, and in this case we're going to get two components of velocity along x-axis and along y-axis, right? So here my point is, if you observe the all given graphs here, you can see in this graph we are getting at the same time two different velocities at the same time, right? So that's why this is a graph of 2D motion. So that's why our answer is B, right? So hope you have understood this. Now let's move on to next question. This is our next question. A ball is dropped vertically from a height d. A ball is dropped from a height vertically d, and it strikes the floor and bounce back to a height d by 2. So which graph of the following represents this kind of motion? Okay, so while it is coming down, initial velocity was 0, right? While it is coming down, right, and then in that case initial velocity was 0, then you see acceleration, that's gonna be minus z, a is equal to minus z, right? And position is minus d now, So let me take this one as y-axis, right, vertical axis. So position is minus d, and so it must have some velocity just before touch the ground. Let it be v. Okay, v is the final velocity. So then we're gonna use this equation, v square minus u square is equal to 2ya. So here v square is v square, u is 0, then y is here minus d, and a is minus z. So what we're gonna get, v square is equal to 2dz. So v will be equal to plus minus root over 2dz, and as it is coming downward, so v will be taken as negative, and this can be written as 4 into half d by 2 into z, right? So you can compare this equation with this, you can compare this equation with this equation, y is equal to root over 4ax, right? 4ax, right? 4ax. So this is the equation of parabola, right? So that's why this is cancelled, right? Okay, so now you see the velocity is increasing while coming downward. So this is v is equal to minus this one, just wait, v is equal to minus this. So velocity is increasing while coming downward. So this is the graph for the downward motion, and when it is going upward, okay, if the ball strikes with velocity v, then it must be bounced back with the same velocity. That's why initial velocity is in this case v, which is positive now, and displacement is also positive now, but here in this case d by 2, right? And acceleration is minus z, right? So let me use the same formula here, just let me clean these things. So while going upward, so v square minus u square is equal to 2yz. Here you see the final velocity at this position will be 0 because it bounced back up to a height only d by 2, right? So here value of v is 0, and value of v, initial velocity, it bounced back with the velocity v, right? So that's why v square, and 2 y is here d by 2, right? And a is minus z, right? The acceleration a is minus z here, so that's why we have got minus v square. So 2 to gone, d minus dz, so minus minus gone, so v will be equal to plus minus root over dz, right? So it is going upward, so v will be taken as positive, and it can be written as 4 into d by 4 into z. So this is also in this form, so that is why it is also in the shape of parabola. So at d by 2, here you see this is d, then this is d by 2, though it is not mentioned here. So here at d by 2 the velocity becomes 0. Here you can see velocity becomes 0. Okay, so here you can see, you may be confused with these two graphs, that here also at this position d by 2 the velocity becomes 0, velocity is decreasing, and here you see while coming from d to the 0 position, d while coming from this height to the ground, the velocity is increasing here also. Okay, it seems to be the same situation, but here you see the graphs are straight line, but according to our equations that we have got, these equations represents parabola, so that's why we have to take this option. Okay, first option. So answer A is correct. So hope you have understood this. If you have understood, please hit the thumbs up button, also share with your friends, and stay connected. Inspire me to create new contents for you. Thank you for watching.